This is part 5 of our video series on sampling distribution theory. I'm Renee Clark from the Swanson School of Engineering at Pitt. In this video, we are going to talk about the topic of the standard normal or Z probability table that's found in the back of statistics textbooks, as well as examples of using this table. This is an example of a table of probabilities or areas, whichever way you want to look at it, under the standard normal or Z curve, okay? And a table such as this is found in the back of most inferential statistics textbooks because a table such as this is used extensively in calculating confidence intervals or running a hypothesis test or other inferential statistical techniques. Okay, so the use of these tables is quite important. Okay, so the first thing that we want to notice is the following. I want to point out the visual legend to you. Okay, so the visual legend will show you a picture of the probability distribution or the curve we are considering. In this case, it's the normal, standard normal Z curve. Okay, so along the x-axis sits the actual Z value. Okay, you can see that it's small, but you can see it. Okay, this Z value is a combination of the row and column headings. So what I have circled in red are row headings. What I have circled in blue are column headings. Okay. Now, just as a quick review, recall that Z is the number of standard deviations above or below the mean of 0. So here is that mean of 0. Okay, that's just by way of review. Now, in order to use this table, the first thing you want to remember is that the Z value, which is formed by a combination of the row and column headings, sits along the x-axis. So the Z value sits along the x-axis of that curve. The numbers in the middle of the table, so all these, okay, they are probabilities or areas under our standard normal or Z curve. Okay, and in fact, based on the visual legend, okay, in this case, they are probabilities to the left of the Z value, which sits along the x-axis. Okay, so let's just delete that right there. As you can see from the legend, the area that is highlighted is actually to the left of that Z value. You can see that. Okay, so for this table, these are probabilities or areas that sit to the left of the particular Z value along the x-axis. Okay, now in the back of your book, there are 2 pages that contain areas or probabilities under the standard normal curve. Okay, now the first page is for values of Z that are negative. As you can see here, going to circle the row header there. Okay, so values of Z that are negative. Okay, so they are values of Z that sit 0 and to the left. Okay, so from this table, you can see that z is as small as negative 3.49. Okay, and that's formed by a combination of the row header and the column header. Okay. Okay. Keep in mind that the probabilities that are shown in these tables are to the left or less than the particular z-value. And again, can tell that just by looking at the visual legend. It shows the z-value and then it shows the shaded area to the left of it or less than it. Okay, so using this table, what is the probability z less than negative 2.51? Okay, so in order to determine this, we go down to negative 2.5. Okay, and then we go across to 0.01, which sits in the hundredth place. Okay, and then from there, we read off the probability that sits at the intersection. So the answer to this question is 0.0060. Okay. What if we want to find out, erase these, the probability z less than negative 3.17? We're going to do the same thing. We go down to, we find z equal negative 3.1. Okay. Then we go across to 0.07, or 7 in the hundredth place. Okay. And we read off the probability or area that's at the intersection of those two. Negative 3.17 is right there, negative 3.17. So therefore, the probability z less than negative 3.17 is 0.0008. Very small probability. Okay, let's try one more. How about the probability z less than negative 0.04? Okay, we're going to go down to here, negative 0.0. Then we're going to go over to 0.04, or 4 in the hundredths. And we are going to read off the probability value that sits at the intersection of those two, which is right there. Okay, so the answer to this question is 0.4840. Okay. Thank you to the National Science Foundation for supporting our work under Grant 233-5802. Thank you for watching.